Hello, I'm Alice Gerlach, and here's the latest update from Spectrum Autism News. Antihistamine aids myelination in Pitt-Hopkins mice, by Laura DeTaro. Last June, Brady Meyer gave a talk about the promise of repurposing existing drugs for people with Pitt-Hopkins syndrome, a rare genetic condition that's often accompanied by autism. Among the compounds he mentioned was the antihistamine clemastine fumarate, which is available by prescription in the United States, often under the brand name Tavist. In addition to easing allergies, clemastine happens to promote the growth of myelin, the lipid layer that insulates neurons like a plastic sheath around a wire. About a month later, Meyer received an email from a parent who had listened to his talk, delivered at a meeting of the Pitt-Hopkins Research Foundation, PHRF, in Chicago, Illinois. Geetika Bajpai's then 2-year-old son, Aiden, has Pitt-Hopkins syndrome, and Bajpai wanted to give clemastine a try. Meyer, lead investigator at the Lieber Institute for Brain Development in Baltimore, Maryland, was unsure. Clemastine is not approved for young children, and there are no data on how children with Pitt-Hopkins might respond to it. Plus, Meyer is a researcher, not a doctor. He suggested she speak to her son's pediatrician, who agreed to prescribe the drug for Aiden's allergies, and see if it had any additional effects. To date, much of what is known about clemastine's myelin-boosting abilities comes from animal studies. But there are hints that the drug improves brain tissue damage in people with multiple sclerosis, a disease in which the immune system attacks myelin and the cells that produce it, called oligodendrocytes. For example, the drug improves optic nerve signaling in adults with the condition, according to 2017 clinical trial results. It's reasonable to think that increasing myelination might similarly ease traits in some neurodevelopmental conditions, including Pitt-Hopkins syndrome. Mice with mutations seen in people with the condition differentially express oligodendrocyte genes and have fewer of the cells and the myelin they make, Meyer found in a 2020 study. Clemastine improves myelination and normalizes brain activity and behavior in the mice, he found in a study published in Brain in April. And the same is true for an experimental compound called sobeterome, which mimics thyroid hormone, necessary for myelination, and for a stripped-down version of the drug called SOB-AM2 that more readily crosses the blood-brain barrier. The mounting evidence is enough for researchers to consider a clinical trial of pro-myelinating drugs in children with Pitt-Hopkins syndrome, Meyer says. Both clemastine and SOB-AM2 have advantages and drawbacks. It's possible clemastine could be trialed more quickly since it has already been approved by the U.S. Food and Drug Administration, Meyer says, but it would likely have more side effects than SOB-AM2. Antihistamines can cause drowsiness and slowed cognition, and both drugs likely need toxicology tests in newborn or very young animals. The animal data look promising but preliminary, says Kimberly Goodspeed, assistant professor of pediatrics, neurology, and psychiatry at UT Southwestern Medical Center in Dallas, Texas. Goodspeed was not involved in Meyer's work, but treats children with Pitt-Hopkins syndrome. It's a really exciting thing to look at, but it probably needs maybe one more mouse or rat study before you actually take it into humans, she says. It's a really interesting proof of concept. Thomas Scanlon read Meyer's 2020 study with great interest. Scanlon, professor of chemical physiology and pharmacology at Oregon Health and Science University in Portland, created sobeterome in 1996 as a treatment for high cholesterol, which is moderated by thyroid hormone. But in the early 2000s, as evidence that thyroid hormone promotes remyelination accumulated, Scanlon pivoted to study the drug in the central nervous system and in 2017 developed SOB-AM2. In 2018, Scanlon co-founded a company now called Autobahn, which aims to test SOB-AM2 and similar drugs in people with multiple sclerosis or major depression. Both sobeterome and SOB-AM2 help mice that lack myelin to regrow the insulation, he showed in 2019. In Meyer's Pitt-Hopkins mouse, Scanlon saw yet another opportunity for SOB-AM2. Scanlon emailed Meyer a few weeks after the 2020 paper came out, at which point Meyer was already studying the use of clemastine and other pro-myelinating drugs in Pitt-Hopkins mice. Meyer agreed to try Scanlon's drugs in his animals. As the team described in Brain in April, cell cultures from Pitt-Hopkins mice had fewer oligodendrocytes and more oligodendrocyte precursors than did wild-type mice, and bathing the cultures in clemastine reduced this difference. Brain slices from animals that had received clemastine injections to the stomach showed the same thing, and the effects lasted nearly 7 weeks after the 2-week treatment ended. Axons from the slices of treated Pitt-Hopkins mice showed signs of more ongoing myelination than those of untreated mice, about as much as wild-type mice, the researchers found using transmission electron microscopy. Electrode recordings revealed that treated mice have a more typical ratio of signals traveling along myelinated versus unmyelinated axons than untreated ones. Meyer didn't test this ratio in the controls. Untreated model mice also behaved unusually in an open area. They scurried around much more than wild types and frequently moved to the center of the space, indicating an atypical lack of anxiety. Both behaviors normalized with clemastine treatment. Administering SOB-AM2 instead had the same effects, and sobeterome restored wild-type levels of oligodendrocyte and oligodendrocyte precursors in the animals. Anyone looking to trial SOB-AM2 in people would need to license it from Oregon Health and Science University, which holds the patent. The patent on sobeterome expired in 2016, but the drug wouldn't be a good clinical candidate for brain conditions, given its difficulty crossing the blood-brain barrier, Scanlon says. He would also need to submit an investigational new drug application to the Food and Drug Administration. The drug has never been tested for safety in people, and there are no data on what doses should be used. It's something to think about in the future, Scanlon says, but it's not going to happen tomorrow. Audubon has no current plans to study SOB-AM2 in Pitt-Hopkins syndrome, Scanlon says. Clemastine, on the other hand, could go into an academic trial now, he says. Such a trial could provide further proof of concept for using myelinating drugs for Pitt-Hopkins, Scanlon says. Though clemastine's sedating side effects and limited brain uptake make it less than ideal for regular use. Neither one of them is perfectly keyed up to go into clinical development. Even so, families with children who have the condition may be eager to join a trial. About 1,100 people worldwide have Pitt-Hopkins syndrome, according to a census managed by PHRF, and the parents are often amenable to trying new treatments, Goodspeed says. After Meyer tested an experimental compound in Pitt-Hopkins mice in 2016, for example, PHRF touted the study as a potential treatment, and several families wanted to try the blood pressure drug nicardipine following a 2020 study showing the medicine improved social and repetitive behaviors in model mice, Goodspeed says. Children who have already tried clemastine would likely be excluded from any trials, Meyer says, but there are 406 children known to have Pitt-Hopkins in the US, and, as far as Meyer knows, only 3 have taken clemastine. The numbers might be higher in Europe, where the drug is available over the counter. Balancing the needs of families and the demands of clinical rigor is difficult, Goodspeed says. If children are taking a drug off-label, it can disrupt formal trials, particularly because parents are often wary of disclosing such use to researchers, she says. You don't want to stop anything, because if something seems safe and effective, that should be their right to try it, she says. But we have to be nimble and thoughtful as we're moving forward. Bajpai, at least, felt prepared to safely test the waters. As a pharmacist, she knows how to measure doses and watch for side effects. For 6 months, Aiden took 1.34 milligrams of clemastine daily, compared with the 5.36 milligrams adults took twice daily in the multiple sclerosis trial. He now takes it only as needed for allergies. Anecdotally, at least, Aiden seems more alert and aware of his surroundings on the drug, Bajpai says. The boy's physical therapist and teacher, neither of whom knew about the treatment, mentioned the changes too. 2 other families trying the drug saw similar results, Bajpai says. That's huge, right? She says. From someone who won't respond his name to someone who you feel like you're actually playing with now. For all the promise, though, there's no guarantee the drugs will be a success. At least one family told Meyer about a negative experience with clemastine. The child became hyperactive after taking the drug and had to stop using it. These kids have obviously much different brain chemistry than we do, Meyer says, noting that antihistamines typically cause drowsiness. Meyer also warns parents that progress is difficult to monitor without objective outcome measures. And because there hasn't been a natural history study of Pitt-Hopkins syndrome, little is known about typical development in children with the condition. Meyer says he plans to do more behavioral tests in the Pitt-Hopkins mice, such as a water maze task that measures learning and memory. If clemastine improves learning and memory in mice, clinical trials in people could measure similar outcomes. He also wants to test whether the drug eases the breathing problems that occur in both model mice and people with Pitt-Hopkins syndrome. Stem cells from people with Pitt-Hopkins syndrome struggle to differentiate into oligodendrocytes, Meyer says. But it is not known whether children with Pitt-Hopkins have reduced white matter like the model mice. Meyer says he also plans to test clemastine in mouse models of other genetic syndromes linked to autism, which could expand the number of people available to test the drug in a clinical trial. Some animal studies suggest other autism-linked mutations cause myelin deficits. Mice with mutations in CHD8, for example, have thin myelin sheaths that seem to impede electrical signals, an independent team showed in 2020. We're not saying myelination is the only problem, Meyer says. This is just one piece of the puzzle and maybe something that would be easy to help.